Design by Babb, that's who I work for. Oh, sorry, is that better?
Yes.
I'm just a little short. The bridge was designed by Babb, it's a company that I work for, and built by a joint venture of Flatiron and Advancing Construction Companies for the Minnesota Department of Transportation. It's located in the heart of Minneapolis. It carries 10 lanes of interstate traffic across the Mississippi River. The bridge opened to traffic on September 18, 2008. It was designed and built in 11 months. It was only about 13 months after the bridge tragically fell that we reopened the bridge to traffic. We opened it 3 months early, restoring a vital transportation link and achieving the Minnesota Department of Transportation's vision for quality, safety, and innovation. And it was their vision that was the driving force behind many of the details that make this a sustainable bridge for the future. So when I talk about sustainable design with this bridge, the things I'm referring to are protecting the environment with eco-friendly materials and practices and creating a lasting design for the future with quality, innovation, and planning for the future. That all started with the community. We had the community select the aesthetics for the bridge. They selected the curved pier shape you see, the color of the bridge, and many of the landscape elements, so that the bridge represents who they are now and how they want to be remembered in the future. And of course, that entered into the design. We wanted to make sure that none of the piers were placed in the water to protect the river environment. So the 504-foot span across the Mississippi allowed us to do that. This elevation view also shows you the arching forms of the bridge with the variable depth superstructure that mimics the arches, the historic arches of the bridges that are already along that corridor. We used high-performance concrete, high strength, and low permeability. We also used self-consolidating mixes for some of the elements. Many of the actual concrete strengths were almost twice what the design strength was specified. That was for the drill shafts as well as many of the other elements. We used concrete maturity meters in the larger mixes. Most of the concrete pouring was done during the wintertime. That's just the way this project worked out. It wasn't the best, and it's really cold in Minnesota in the winter. So this helped us to make sure we were getting that quality concrete design in the winter. And then, of course, the superstructure. This is a box girder. This is what makes up the part of the bridge that you drive on. Here, permeability was really important, so we used a variety of admixtures to make sure that the permeability was kept low. And this is just a shot of the actual construction. These segments were lifted onto the bridge. The entire main span, 504 feet, 120 segments, was constructed in 47 days. It's an amazing accomplishment. But you can see, even with this, we protected the river. We didn't have any temporary works to protect that environment. There was a special corrosion protection plan that was implemented here to provide a goal of 100-year service life. We really want this bridge to last for the future. Part of that was the rebar design. We used 3D integrated drawings like these to allow the iron workers in the field to interact with the designers. They could plan out the layout for the rebar. They could work together, turning layers on and off to see just what order they were going to set these bars in. And also it applied to the high-strength tendons that run the length of the bridge. These tendons are protected in 3 ways. They're a little bit closer, she says. Okay, sorry. Just wave in the back if you can't hear me. And I have a cold, so I'm really talking even softer so my voice lasts. These tendons are encased in 3 layers of protection. They're inside the concrete, they're inside the duct, and then they're encased in grout. So this is done for the highest quality so that things will last. A lot of people have never seen the inside, so I want to throw this picture in so you can see what it looks like. Along the left and right sides, you can see those ducts I was just talking about. Those carry the high-strength steel tendons that are stressed 10 million pounds that carry the load of this bridge. And along the top, you can see the ducts for the utilities and the drainage. Sustainable design also continued into construction. We had local manufacturing of these segments. You can see in the background of the picture the bridge under construction. The casting yard was set up on an existing part of the roadway that wasn't being used. so that they didn't have to go very far and saved energy. We used recycled materials. Recycled aggregate was used in the new roadway. Landscape elements and drainage, like I talked about, was routed through the bridge into treatment facilities rather than allowing the deck runoff to enter the river. And of course, there are many new innovations and new technologies, and these are some of the exciting things that we'll have for the future. The gateway monuments are 30-foot tall, curved structures that mark the river crossing. The profile for the bridge is such, the first time I went across it, I had no idea I was crossing the river. So they wanted something to mark so that drivers knew, hey, you're crossing the Mississippi River. And these do that. And they're built with a new cement that cleans the air and is also self-cleaning. And it was the first use of this cement in North America.